Mach-wave silencer airplane. For decades, the quest for viable commercial supersonic flight has been a dream that eluded aircraft designers and engineers. But it seems NASA has finally cracked the code with the X-59. At first glance, the X-59 looks like a Frankenstein's monster of aviation. Its elongated fuselage is an amalgamation of parts scavenged from iconic aircraft like the F-16 Fighting Falcon, the Northrop T-38 Talon, and the legendary Lockheed F-117 Nighthawk. But this unconventional design is deliberate, a carefully crafted solution to a perplexing problem, breaking the sound barrier without generating the sonic boom that comes after. But how did NASA come up with such a design? And what groundbreaking features does this aircraft have? In the wake of the Cold War, the United States and its allied nations embarked on an ambitious mission to develop supersonic passenger jets. However, the ear-splitting sonic booms produced by these aircraft quickly became a serious issue, ultimately leading to the Federal Aviation Administration's total ban on commercial supersonic flights over land in 1973. This regulatory roadblock effectively grounded the Concorde, the pioneering Anglo-French supersonic transport designed to transport passengers across oceans at twice the speed of sound. Despite its technological marvels, the Concorde's thunderous sonic booms rendered it an impractical option for overland routes, confining its operations to transatlantic corridors between 1976 and its retirement in 2003. But the allure of supersonic travel has never waned, and in recent years, a resurgence of interest has sparked a new partnership between NASA and Lockheed Martin's renowned Skunk Works. In 2018, this collaboration gave birth to the X-59 Quiet Supersonic Transport Quest project, a daring initiative to develop an experimental aircraft capable of supersonic flight without generating the dreaded sonic boom. Dubbed the Low Boom Demonstrator Project, this audacious venture aims to achieve a breakthrough that could revolutionize aviation. While the X-59 is not designed for passenger transport, its success could pave the way for a new generation of commercial supersonic aircraft, drastically reducing travel times worldwide while respecting the sanctity of quiet skies. Achieving this feat, however, would be no simple task. The contract to design and build the X-59 prototype alone exceeds $250 million. The X-59 represents a bold step forward in aviation that could unlock a new global market for aircraft manufacturers and drastically reduce travel times for commercial passengers worldwide. This cutting-edge aircraft is expected to reach a staggering Mach 1.4, or 925 miles per hour, while cruising at altitudes exceeding 55,000 feet. Yet, despite its blistering speed, the X-59 is designed to generate a mere 75 decibels, equivalent to the level of sound you hear from a car door closing or a casual conversation in a restaurant. With a final length of 99 feet, a height of 14 feet, and a wingspan of 29 feet, the X-59 cuts an imposing figure on the tarmac. Its maximum design gross weight of 25,000 pounds, fuel capacity of 8,700 pounds, and payload capacity of 600 pounds underscores the engineering prowess required to achieve such a delicate balance between speed, efficiency, and noise reduction. Following Skunk Works' selection to design and fly the X-59 in 2018, the company wasted no time pushing the envelope. In June 2019, they unveiled groundbreaking study results and conceptual designs for the aircraft, paving the way for its physical realization. 6 months later, in December 2019, the X-59 garnered widespread acclaim, earning the prestigious What's New award from Popular Science in the aerospace category. The final assembly of the X-59, including the integration of its nose and intricate subsystems, was achieved in October 2021. According to Lockheed Martin's progress reports, the X-59 successfully endured critical structural load and fuel calibration testing a year later. If you're enjoying the video so far, be sure to hit that like button and subscribe for more content just like this. One of the X-59's most remarkable features is its unconventional cockpit design. Instead of the traditional forward-facing windshield, the pilot is greeted by a state-of-the-art 4K monitor that serves as their primary window to the world. This innovative external visibility system stitches together images from external cameras and combines them with terrain data from advanced computing systems, providing the pilot with a virtual yet comprehensive view of their flight path. While the cockpit lacks a direct forward view, it does feature 2 windows and a traditional canopy, allowing the pilot to maintain a view of the horizon. Completing the external visibility system are additional displays that provide critical aircraft systems and trajectory data, ensuring the pilot has all the necessary information to fly safely and efficiently. While the X-59's fuselage and cockpit designs are undoubtedly groundbreaking, the aircraft's wing truly stands out as an engineering masterpiece. According to Lockheed Martin, the X-59's wing is arguably the most complicated of its kind, a testament to the immense challenges in shaping supersonic flight while mitigating its thunderous side effects. The fuselage is a dedicated section meticulously fabricated by Lockheed Martin using advanced robotic manufacturing techniques. This cutting-edge approach was necessary to achieve the exacting tolerances and precise contours required to minimize sonic boom generation. The X-59's tail assembly is equally impressive, a heat-resistant structure that houses the aircraft's robust engine compartment. Designed to withstand the intense thermal loads generated by the X-59's potent propulsion system, this robust assembly protects the aircraft's sensitive components from the searing exhaust of its engine. At the heart of the X-59 lies a General Electric F-414 engine, a 13-foot-long powerhouse capable of delivering an astonishing 22,000 pounds of thrust. This state-of-the-art powerhouse propels the X-59 to its supersonic speeds. At the same time, the aircraft's innovative design works in tandem to suppress the resulting shockwaves and to minimize the audible disturbance. In May 2022, NASA revealed its plans to demonstrate the X-59's ability to break the sound barrier without generating the characteristic loud sonic booms that have plagued various supersonic aircraft. This phenomenon has been the primary reason for governments worldwide to ban supersonic flight over populated areas, a restriction that has long hindered the development of viable commercial supersonic transportation. As the X-59 inched closer to its maiden flight, anticipation mounted within the aerospace community. In June 2023, Lockheed Martin released images showcasing the latest progress on the supersonic aircraft, hinting that ground tests were imminent. A source revealed that the X-59 had been moved to run a stall on the flight line in Palmdale, California, where it would undergo critical vibration and ground testing, bringing it one step closer to its maiden flight. As the 50th anniversary of the ban on commercial supersonic travel over land approached in April 2023, NASA seized the opportunity to provide an eagerly awaited update on the progress of the quiet supersonic transport mission. In a press release, the agency announced its plans to fly an X-59 test aircraft to Mach 1.4 for critical noise trials later that year. NASA personnel emphasized that these noise trials would be instrumental in gathering data to analyze the feasibility of conducting supersonic operations over land. After years of meticulous planning and engineering efforts, NASA and Skunk Works were finally ready to achieve a breakthrough that could redefine the aviation industry. The path to this momentous milestone was not without its challenges. After installing the X-59's tail section in late March 2023, NASA confirmed that the aircraft would undergo an extensive 9-month testing period. This initial phase would focus on rigorous safety and performance evaluations, ensuring that the X-59 met the stringent standards required for its mission. Once this critical trial period concluded, Lockheed Martin would hand over the reins to NASA, delivering the aircraft to the agency's capable hands by mid-2024. From that point forward, NASA's highly skilled personnel would spearhead Phase 2 of the testing program. The X-59 would take to the skies above the Supersonic Test Range, a vast swath of airspace spanning the Armstrong Flight Research Center and Edwards Air Force Base in California. If successful, these tests would not only confirm the viability of the X-59's noise reduction technologies, but also validate the aircraft's overall safety and performance capabilities, paving the way for the next phase of the program. Phase 3, slated to commence in 2025 and continue through 2026, would involve a series of flight trials over various regions of the United States. During these trials, American citizens exposed to the X-59's supersonic passages would be surveyed to gauge their reactions to the perceived sound levels generated by the aircraft. These public perception surveys would play a pivotal role in the potential reconsideration of the 1973 ban on supersonic overland flight. The data collected would be meticulously analyzed and shared with regulatory bodies, including the National Airspace System and international aviation authorities, providing a comprehensive understanding of the X-59's impact on communities and the environment. With each successful phase, the X-59 inched closer to realizing its audacious goal, enabling a new era of practical, quiet supersonic travel, ushering in a future where time and distance are no longer insurmountable barriers, yet the tranquility of the skies remains undisturbed. If you enjoyed the video, be sure to hit that like button, subscribe to the channel, and turn on the notification bell to be notified whenever we post amazing videos like this.